We now discuss the solution of a problem from the section matrices and determinants. And the problem is also based on the inverse of a given situation. This problem has appeared in joint entrance examination main held on 27th July 2021 in the second shift. The problem is, let A and B be two 3 by 3 real matrices such that A square minus B square is an invertible matrix. If A power 5 is equal to B power 5 and A cube B square is equal to A square B cube, then the value of the determinant of the matrix A cube plus B cube is equal to, the four options are given to us. Option 1, 1. Option 2, 0. Option 3, 2. Option 4, 4. So we are given two 3 by 3 matrices, real matrices, capital A and capital B. And it's also given to you A square minus B square is an invertible matrix. And you are further given A power 5 is equal to B power 5 and A cube is equal to B square is equal to A square into B cube. Then you are asked to find the determinant of the matrix A cube plus B cube. The four options are here. Let's now discuss the solution of the problem in detail. We are given two 3 by 3 real matrices, capital A and B, and you are also given A square minus B square is an invertible matrix. This implies its inverse exists, that is A square minus B square inverse, whole inverse exists. You are further given A power 5 is equal to B power 5 and A cube B square is equal to A square B cube. Now from A to the power of 5 subtract A cube B square, then that will be equal to, from B to the power of 5 subtract the equal of A cube B square, that is A square B cube. And we are required to find determinant of A cube plus B cube. So this will imply A to the power of 5 minus A cube B square is equal to B to the power of 5 minus A square B cube. Why? From A to the power of 5 you have subtracted A cube B square. Then from B to the power of 5 you have to subtract the equal of this, namely A square B cube. Now on the left hand side A cube is common, take A cube common, then you will get A cube into A square minus B square is equal to, on the right hand side B cube is common, B cube into B square minus A square. So that will be, this is the situation. Now this B square minus A square on the right hand side, you write it as minus times A square minus B square. So you got this one. Now what you see is A square minus B square is appearing, and you are tempted to cancel this and get the answer. Yeah, is it valid? That is the question. Now let's see. This is what you have, and now what you do is we will cancel. This is equal to A cube is equal to minus B cube. By what? By cancellation. The cancellation is valid because A square minus B square is invertible. If A square minus B square is not invertible, this is not true. You cannot cancel. So because the common factor on the on both sides is there on the same side. So you can cancel because it is invertible. So it is invertible means a cube is equal to minus b cube we got, and from that a cube plus b cube is equal to the zero matrix. This is the zero matrix. Bold 0 means zero matrix. Now take its determinant. Determinant of a cube plus b cube is equal to determinant of zero matrix. Determinant of zero matrix is 0. Yeah, that's what you have, and you have found the determinant of a cube plus b cube, and that is which is equal to 0, and your problem is over, and you got your answer. This is how you can do it from here by cancellation. Suppose you are not cancelling. Then what we have is a cube into a square minus b square is equal to minus b cube into a square minus b square. Now, what we have is a square minus b square is invertible. That means a square minus b square inverse exists. Therefore, post multiply both sides by a square minus b square whole inverse. So, post multiply. So, if you post multiply, what do you get? A cube into a square minus b square multiply, post multiply a square minus b square inverse is equal to minus b cube into a square minus b square post multiply a square minus b square inverse. Now, any matrix any matrix multiplied by its inverse is the identity. So therefore, a square minus b square into a square minus b square inverse is identity. So also here. So you will get a cube into identity is equal to minus b cube into identity, and that will imply a cube is equal to minus b cube. And that's what we said there. That is by cancellation that will go away. But the steps are this, and you can take that as a shortcut also. But that is valid only when this a square minus b square inverse exists. So this will imply a cube plus b cube is equal to the zero matrix, and take the determinants on both sides. Determinant of a cube plus b cube is equal to the determinant of the zero matrix. The determinant of the zero matrix is the scalar 0. So thus we got the determinant of a cube plus b cube, what is asked in the question, and our answer 0 appears against the option 2. Therefore, our answer is option 2. And that is the discussion of the solution of the problem from the section matrices and determinants. Matrices and determinant, and it is a straightforward question. I hope that you have understood the solution of this problem, and I wish you all the best. Thank you.